like I was saying, we're going to find, of course, that we're going to have a center in the brain that is going to work on controlling breathing. So, one of the things that we need to be dependent upon, we need to have repetitive stimulation of the skeletal muscles. The brain center is going to help with that. Because of where that breathing center in the brain is located, everybody kind of see where they're showing this area right here? Recognize any of that? All right. We are seeing that we're at the area of the pons, the medulla oblongata. We are very close to this area of the spinal cord. Ever known somebody who had a very high up severing of the spinal cord in an accident and survived? Most of the time they do not, because this is the point that if it's like, if there is a severing of the spinal cord anywhere near between the base of the brain and C1, because you guys remember the atlas and the axis, C1 and C2, okay? When that happens, that part, even if their head does not come off of the body, that person has suffered decapitation. It would be equal to the head severing from the body. Do any of you happen to remember Christopher Reeve?
Superman.
The Superman. The first Superman? Yeah, I'm getting a little too old. Okay, but do y'all, Brian's with me on this one. Okay, he had that horse accident where it broke, basically, that's where he got severed. He survived decapitation. That's why after, as everything happened, that he had to remain on the respirator, because that was the only way he could breathe. Something had to breathe for him. So, this point, all right, anything that severs close to this area most likely is going to cease these activities, and the person is not going to survive it. We also have, coming from this region, do you see how they're trying to show this PRG, this VRG, and DRG, okay? They are going to be groups of neurons. So, we're going to get innervation to those skeletal muscles. However, it's going to require nerve stimulation. Well, let me think here for a second. I wonder what it's going to be that causes those nerves to get stimulated to send a response. This is where it gets a tad bit interesting for breathing. For all of this to work together, for us to have the areas of the brain, the innervation to these skeletal muscles, especially these intercostals, the innervation to the diaphragm, okay? I need them to work very well coordinated, okay? Meaning, breathing in and breathing out, being a rhythmic movement. Otherwise, if it wasn't, how do you think breathing would be? If I didn't have nice rhythmic movement of these intercostals and this diaphragm at the same time, I'm going to have very labored breathing. All right? That's going to affect all the other processes that have to take place. So in the brainstem, where I have my respiratory centers, that VRG, DRG, PRG, we're looking at, for the VRG, if we come over here, and if we follow PRG, DRG, VRG, I'm in the area of what right here for my brainstem? I'm in the area of my pons. So for PRG, that is simply the pontine respiratory group. When I look at the two groups right here, almost looks like they're coming down our throat, okay? But these are really in areas of the medulla. Well, if I've got these two groups positioned like this, one of them is ventral, one of them is dorsal. So therefore, I have a ventral respiratory group and a dorsal respiratory group. Note some of these other connections that are being seen right here. Chemoreceptors. What did chemoreceptors detect? What specifically did they focus on in the blood? CO2, which causes an effect on what in the blood?
pH.
The pH. Wait a minute. What gases move with respiration? O2, CO2. Which one affects my pH? CO2. These chemoreceptors have a connection to which group? Dorsal or ventral? It's a connection
Dorsal.
to my dorsal. In the dorsal group, faster, slower, shallow, deeper. Therefore, it's having an effect on my inspiration. So we are looking at the DRG based upon information from the chemoreceptors that are found in these regions with these respiratory groups, having an effect on how fast or slow I breathe and on how shallow or deep. Does that make sense? If I come over here and look at my ventral group, and they're trying to show me the representation of a nerve here. They're trying to show that from my dorsal to my ventral, I get an effect. In this ventral group, they're showing that I can have an effect on the pontine, okay? Trying to show us our connections that we have. Now, as we look, this is coming down the spinal cord, affecting those muscles, okay? So, if we think about these groups, ventral, the primary generator is my ventral group. Their neurons are on a reverberating circuit. It literally looks like these The firing goes boop, 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 boop. A reverberating circuit. It looks like it never stops, and it doesn't until death or breathing stops, and you bring it back. For the Pontine group, if this one is my primary generator, if this one will make me breathe faster, slower, shallow, deeper, okay, this right here helps with the rhythm. Making sure that this in, out, the inspiration, expiration are occurring rhythmically. So, those respiratory groups are going to get pretty important. When we begin to think about how these, if we look at those chemoreceptors, the chemicals, i.e. the CO2, which is affecting the pH, which of course will affect my oxygen levels too. However, CO2 is the biggest factor, okay? So, I have my central chemoreceptors, meaning they're in my central nervous system. These are the ones that are in that medulla oblongata of the respiratory center. I have peripheral, meaning out to the outside of that central nervous system. These are in my carotid. Where is that? Through the neck. And the aortic. Where's my aorta?
To the heart.
Off the heart. Okay? The connection is by way of cranial nerves. Now look at this right here. In that smooth muscle of the bronchi, bronchioles, and viscera pleura, I have stretch receptors. What's that? The expanding and the contracting. Wait a minute. Do I really have to worry about the ability of the lungs to expand and contract?
Yes.
I mean, could they over or under?
Yeah.
Yes. So, we're going to have receptors that are going to be located, and they're going to pick up information about how much we have of the expansion of the lung tissue, because there is it is in space that is restricted. There is not any type of unlimited space here. So we have what's called the Herring-Brewer reflex. With the Herring-Brewer reflex, based upon these stretch receptors that are present, action potentials will get started. We'll inflate the lungs. They'll pass by way, that stretching, that information passes by way of those cranial nerves, and then we end up getting information about, okay, well, they have expanded. I need to stop that. So we'll end up getting an action potential that's inhibitory, come back and stop the expansion. So the Herring-Brewer reflex, based upon how big or how constricted the lung tissue actually gets, controls or contributes, I should say, to the amount of stretch that can occur in the lungs. Now, other things that are present that play a part are just receptors that pick up on irritations. something that might be tried?